Hi, thank you for watching. My name is Oliver Rossi. I am a solutions architect for DataCore Software, the leader in software-defined storage. So today I'm going to show you how to perform storage migration using DataCore storage virtualization software, SANsymphony-V. So first off, let me start by describing our software-defined storage solution. Then I will discuss how migrations are performed using DataCore SANsymphony-V. And then we'll finish up with the demo. SANsymphony-V enables the virtualization of any block storage devices, regardless of make, brand, or model. Whether that storage is directly attached, or it is internal storage, or SAN-attached storage, or even storage running close to the application like PCIe flash devices. Our software is inserted in path between the storage devices and the consuming host and applications. You can then centrally manage and pool these storage devices, which also enables an advanced set of storage services that allows you to perform all storage-related tasks such as synchronous or asynchronous replication, snapshots, CDP, auto-tiering, etc. DataCore was founded in 1998 with the idea of building what we call then software-driven storage. While major storage manufacturers at the time were busy adding features and capabilities to their array, DataCore took a different route. It built its set of storage services into a software package, allowing already back then to break the vendor lock. So fast forward to today, the storage landscape is a giant mess. We have SANs, we have NAS, we have direct attached storage, we have hyper-converged system, we have the cloud, we have a myriad of flash-based array and hybrid array, none of which can actually be centrally managed or pooled, and all with their own siloed set of storage services. So it's no wonder why even major hardware storage vendors are scrambling to build a software-defined storage solution. There's many claims to software-defined storage solution in the market today. This is what we at DataCore think it should enable you to do. Basically break the vendor lock, allowing all storage devices to communicate with one another without any restriction whatsoever. You should be able to centrally manage all storage devices and pool their capacity to get rid of the stranded space on siloed storage. You should enable an advanced set of storage services that applies to all devices uniformly by separating those capabilities from the underlying storage hardware. Finally, it should also enable fluid and transparent and non-disruptive data movement across storage devices. Ultimately, it will simplify the hardware maintenance and make the migration a snap. Okay, so this is the complete feature set of our software. It is pretty mature and proven software-defined storage solution. We're already at version 10, and we have over 25,000 deployment worldwide. Let's talk about data migration. Why would we want to do them in the first place? Many reasons for storage migration. Maybe your storage array needs a hardware refresh because it's end of life or end of lease. Maybe the performance is no longer adequate for the consuming application, or simply you're running out of space. So with DataCore, you can move blocks non-disruptively from one device to the next. You can reclaim stranded capacity in white spaces and even virtualize existing arrays without affecting the stored data using our pass-through capability. Okay, data migration. We typically deploy our software in pairs for high availability and to avoid single point of failure. As you can see, we insert right in between the consuming host application servers and the storage hardware. If you have an existing SAN, you will use our pass-through capability to ingest the array, virtualize it, and present it back to the host. In this case, we don't touch existing partition. We pass the data right back to the host, but enable our storage services. Once the storage is under DataCore control, you can move blocks around very easily using at the virtual disk level. That's how we call our LUN. Storage, move, and replace, snapshots, auto-tiering, sync or async replication, and at the pool level, you can perform a complete array replacement using in-pool mirroring. All these operations can be performed without downtime. This slide describes how to establish pass-through. Okay, the left part of the slide represents how your storage subsystem might be connected by a redundant fabric to the consuming host. On the right, I just show you how to insert two DataCore servers connected to each fabric. The DataCore servers have backend ports to consolidate storage resources, mirror ports to enable mirroring between devices, and front-end port to provision storage to the host. On the left switch, you can see the parallel zoning that needs to be put in place for DataCore to enable pass-through. Simply put, the DataCore backend port needs to see the old storage array, and its front-end port must be connected to the host. Makes sense, right? Once the plumbing is done, you really can decide whether to pass through all the LUNs in one shot or one at a time. It really depends on the downtime that you have available for each of the application. Because as you've probably guessed, inserting our layer requires a minimal interruption, though I can assure you it's far less disruptive than performing a 500 terabyte host-based mirroring migration, for instance. So once you've presented the storage arrays LUN to the DataCore server, we discover them, we virtualize them, and serve the corresponding virtual disk back to the host to resume I/O operation. Well planned, this interruption can be extremely short, as every step can be scripted with our PowerShell commandlet. You remember the second DataCore server? It is connected to the new array and also has mirror ports to its peer and front-end ports to the host. At some point, either while you were ingesting the old array as pass-through or after the fact, you must create a mirror of the pass-through LUNs to resources from the pooled storage on the second DataCore server. So the host is going to consume the mirrored virtual disks as an active-active multipath disk device. For now, think of DataCore 1 and DataCore 2 as your two controllers. That's really what it is. What that means is you can replace or move either side of this mirrored virtual disk without impacting your consuming host, while a replace operation induces a path failure on the replacement side. A move operation is, however, a little bit more subtle because it creates a background copy of the data on the side that you decided to move the storage from. And whenever that background copy is completed, we simply switch over. So with the move, you really never ever lose HA. By the way, I just wanted to point out that here on this slide I'm showing pooled storage, right? But you can obviously change storage sources as you please. You can have pass-through to pass-through, pass-through to pool, pools to pass-through, any combination. Really with DataCore we don't lock you out. So in other words, you can very easily migrate in, easily migrate out if you want to. So snapshot is also a way for you to migrate from one storage subsystem to the next, though I would probably use this technique more for archival purposes, right? So here's a scenario, for example. You have LUNs that are no longer used and you want to take the data off your production pool, right? Because it's just wasting space and your tier 1 space, and you want to move that to an archival array. Well, you can snapshot a virtual disk from pool A to pool B. By default, it's differential, but the snapshot can be full clone. Once the clone is completed, the snapshot can be split and source data discarded and use space automatically reclaimed. Now, when you implement auto-tiering with DataCore, the data is going to migrate on its own. Here are the basics. Auto-tiering measure frequency of read and write access to each block of every virtual disks and move these blocks to the appropriate tier right away while respecting, of course, front-end I/O. So in other words, it's doing sub-LUN auto-tiering. So while this block progression occurs naturally based on our auto-tiering live ROI calculations, the tier affinity of any given virtual disk can actually be dictated through what we call storage profile. This can be changed live, inducing background migration to the chosen tier, again while servicing front-end I/O first. So this is really more for natural progression of data across tier, but is also a form of migration. Okay, so the last one that I'm going to present here is in-pool mirroring. So when you manage storage with DataCore, moving forward, you know, complete array replacement are very easy to perform and absolutely 100% non-disruptive. If you want to replace a pooled array, simply mirror all of its LUN to LUNs that were issued from the new array, and this operation, since it happens in the pool below any host presentation items, that means that the host has absolutely no clue of what's going on. The mirroring happens within the pool without affecting any of the paths that the host has in order to access to its storage. Okay, so that was the last one I want to talk about. There is one that I didn't mention, which is migration using async replication. So we have async replication part of our product, and while it's completely possible to migrate data using asynchronous replication, it's typically not something that people do, right? You're not going to migrate petabytes of data over the wire across the globe. In the meantime, just know that it's another form of replication that we have, and therefore another way for you to move data and migrate data from one array to the next, but probably not the most practical one. Okay, well, I think now we're ready for the demos.
Alright, so let's first see what type of data we have to work with. The first machine I'm going to RDP to is my client machine. So this is a 2012 server on which I have provisioned a LUN from a .hill array. You can see the D drive here. I labeled this movie. I put a few movies on there just so we have some data to work with. You can see those movies here. And the next set of data that we're going to work with is actually on a VMware. So some of you will actually argue that yes, you can use storage vMotion to move data around. That's fine. Storage vMotion has its own limitation in the sense that you can only vMotion so many VMs at the same time. What if you needed to do massive migration? Okay, so the point is really to show you the two different type of OSs. You know, more one of this Unix based and the other one that is Windows based. So here you can see I have this Nexan target device here provisioned to my ESX host. Here's my data store on which I'm running a VM, and here's the VM. Okay, so the very first step we're going to do is we're going to stop the VM, so I can just shut it down directly. Okay, so that VM is off. Okay, we're going to turn it off. I'm going to close the data store, and at the host level, what I'm simply going to do, just to simulate that I am quiescing down the machine, I'm going just simply to remove the drive litter, right? That should suffice. Okay, now the next step is to provision the storage to the DataCore server. So before serving the storage to the DataCore server and discovering the LUNs here, obviously I need to unserve the storage from the existing arrays to my ESX host, here in this case, as well as my client Windows machine. So here, as you can see already, that VM is gone. That storage subsystem here is obviously no longer there. We're going to kick a little rescan to make sure it's completely gone, right? And we'll wait for it to completely disappear. Okay, let's validate our Windows host to see and make sure that this LUN is gone. So let's rescan here. Yes, it is really gone. And if I go to Device Manager, that LUN is obviously gone. So let me give you a very brief overview of the DataCore SANsymphony-V interface. So this is our management console. This management console is currently connected to the server group called SFO-Twin Peaks, in which I have two DataCore servers set up for synchronous replication. We will be leveraging DataCore Server 1 to do our pass-through, and we will be mirroring to DataCore Server 2. These two servers are in charge of consolidating the storage and discovering the storage that is being presented to them so that you can then create disk pools. Out of the disk pool, create virtual disks, and then in turn present to your hosts that are defined down there. You can see these are all the different physical disks that are attached to the system. I have a full list here to the right. Some of them are already in pools. Some are ready to be pooled. Available resources. Then here is a pool. So an example of a pool, you see its aggregated capacity of multiple physical disks. In this particular pool, you will note that I have different tiers. Okay, and these different tiers essentially allow for auto tiering. You have here a visual representation of how the data is actually being placed across the multiple tier of storage based on the auto-tiering algorithm or based on whatever storage profile we have defined to assign tier affinity for a given virtual disks. So out of disk pools or physical disk, you create virtual disks. And the virtual disk is how we call our LUNs. Those virtual disks have many properties. So here, for instance, I'm going to show you a mirrored virtual disk between DataCore Server 1 and DataCore Server 2. You can see that it has two different storage sources, one that is local to Server 1 and one that is local to Server 2. The replication between the two servers is bidirectional and with multiple ports. Right here you can see all the different paths that are defined and that allow to provision that virtual disk for consumption by my two ESX hosts defined here at the bottom. Okay, so that's very simple. I mentioned a little bit earlier how the migration is done. Well, the first piece is to establish the mirror, so that's what we'll do. Then the second piece is to leverage those functions, the replace and the move, to actually get out of a storage subsystem onto a new one. At the bottom here, this is where my hosts are defined. So I already have predefined my vCenter app. I wanted to show you how easy it is to define a host. So here, currently my host is this Windows system that we talked about a little bit earlier. I'm just going to show you how you register a new host. Okay, so here's the host. So let me give this host a name and pick the right OS. Okay, there's a difference between Windows and 2012 as we do support ODX, extended set of commands. I will enable multipath here because I have actually enabled support on my host, and here all I have to do is register. And if I take a look at my host, now I can see that this host is actually connected to DataCore Server 1 and DataCore Server 2 via multiple paths, right? So I have full redundancy of paths, I have multipath capability, and I can do failover, failback between the two. So that's essentially all it takes to register a host. Now we are going to ingest storage from the old array so that we can discover it, create a virtual disk to it, and then serve it to the host. Okay, so I went to my backend storage subsystem, my .hill array, and I provisioned this LUN directly to the DataCore Server 1. So first, what I did is I unprovisioned it from my host that was consuming it. Then I provisioned it to my DataCore Server 1. After a rescan, right, it can be done here by a simple right-click. This line shows up. By the way, here you can see all the different detail information that we can pull and that we can read. So imagine how you can easily script against an NAID, and essentially in a spreadsheet, if you can have a report displaying the NAID corresponding host as well as label of that line, then it becomes very easy to automate all this and script all this. So very first step I'm going to do is I'm going to create a virtual disk out of that line, right? So we're going to make this very simply. We're going to create a virtual disk, so I'll create a single virtual disk so that you understand how this is done. I'm going to call this my movies. So pretty simple. I can put whatever comments I want. Here, in terms of the size, it will automatically self-adjust. Here I am prompted for whether I want to use a pool storage or pass-through disk. Obviously here we're doing a pass-through disk, so I have to discover this LUN here. Here it is. By the way, all these can be renamed, right? And when you run a script, the script doesn't really care about the name. But for you, if you want to do this visually, you could rename the LUN. And here I'm just going to hit finish. Virtual disk size doesn't match. That's expected. I'm just going to say yes. It auto adapts, right? And here it is. Here's my movie. And I'm going to provision this movie virtual disk to that host that we just defined a little bit earlier. So serve the virtual disk, pick the movie, say next, finish, and I am done. So essentially that's all it takes to do a pass-through. Okay, so let's take a look at our host, and we're going to rescan. So here's my host. We're going to rescan here. Okay, so here is a DataCore Virtual Disk multipath disk device. If we go into disk management, here I can see it's offline. Let's bring it online. And I can see I have a movies. And if I change my drive letter and path and re-add this drive letter as I had earlier, okay, we can now browse and explore this line, and we see that we have our movies there. Okay, so that's essentially the pass-through mechanism. Okay, so pretty simple. Now, if I want to start migration, very simply, all I need to do is mirror. Okay, so I'm going to show you how to create a mirror, and then we'll go ahead and do the same thing for our ESX host. Okay, so let's go back to our console here. And all I have to do is I need to simply convert this to a mirrored virtual disk. So on the fly, while I'm using this, I am prompted for the partner server within the same server group and two different pools of storage, and I decide to pick my pool 1 here because that's my auto-tiered pool, and eventually, since I'm playing movies, there's certain that I'm going to read more frequently than others, so I'd like to have this auto-tiered automatically for me. Say add. Okay. And what it's doing right now is says, okay, well, you just created a mirror, so we need to resync. And since it's the first time we sync, we have to do a full recovery. What I would like you to pay attention to is the paths. Notice how all the paths are being created automatically, so it creates all our mirror paths, and at the same time it creates the host paths. Then as soon as the mirror recovery is completed, we will have the ability to do replace and move and so on and so forth. Okay, so let's do the same operation for our ESX host. Okay, so what I've done is I went ahead and I made my LUN pass-through and I created my mirror right away. And now we will provision this to our ESX host. By the way, here's the other mirror recovering while we're consuming data. Okay, so we're going to provision this virtual disk to the ESX cluster, right? And it's in the middle of recovery, but it doesn't really matter. This will complete whenever it completes. So I can right-click here, say Serve Virtual Disk. I'm going to pick my 2K12 generic DC pass-through virtual disk, say Next. Here I'm prompted whether I want redundant path or single path. I want redundant path. Here, this is the integration, a nice little plug-in integration that we have here. In case you were provisioning a LUN that didn't have any data, you would be able to create a VMFS data store on that Discover disk. So out of band, we send all the necessary command to vCenter so that you can create a VMFS data store. Obviously, that's not what we want to do here. And we have the ability also to pick our path policy here. I'm going to stick to round robin, and I'm going to hit finish. Okay. So what this does, if I look at the virtual disk, right, it creates multiple paths, right, and this is currently provisioned to server VMware 01. Now I'm going to provision that to the other server as well. Here, I'm going to say serve virtual disk, provision this to server 2, and here, as you can tell, this virtual disk is not in a list. I have to show serve virtual disk, and I have to go fetch the exact same virtual disk here. I'm going to say next, redundant path, round robin, and here I'm going to get a warning telling me, are you sure you want to do this? You're provisioning this virtual disk to two hosts at the same time. These hosts better be clustered. So we have safety guards and error messages here to prevent you from doing something foolish. Here, this is obviously a cluster, so I can provision this without any problem. So now let's take a look at our ESX host, and what you can see here is that it is doing all the rescan on its own. After the rescan has completed, all that there is left to do at this point is move away from the old array. If we take a look at this data store that we have presented, we see here that it is still passed through on one end and on the other side part of the pool. Just use either the move or the replace. So let's do that. And I'm simply going to move to a pooled storage. This is it. What happens here in the background is that we're making a background copy of the mirror, and as soon as this copy is completed, we will point to the new pool of storage and get rid of the pass-through. Let's do the same thing for our movie virtual disk, and here in this case we're just going to use the replace. So you see how this particular virtual disk is going into a full recovery because we've just replaced one side, while the other one has no loss of HA, right? So if we take a look at this, we're essentially doing the moving, and when the moving is completed, we will point to the new side of the mirror, while here we are indeed waiting for a full recovery.
Alright, this concludes our storage migration video. I hope you found it useful. Thank you so much for reviewing it. Feel free to contact me directly if you have any technical questions, and also feel free to download our trial software and call me if you need any help setting it up. Thank you, and see you on my next videos.